Hi, in this video we will discuss about the Coulombs law. What's the Coulombs law? Well, Coulomb, one of the persons that has laid the foundation on our knowledge in electrostatics, Coulomb discovered the magnitude of the electric force between two charged particles is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. And this relationship between quantities is known as the Coulomb's law. Mathematically, this can be expressed as Fe, or your electric force, is equal to K multiplied by the product of the absolute values of the charges of the two particles divided by the square of the distance between the particles. There, Fe is equal to the magnitude of the electric force in newtons, Q1 and Q2 are the charges in coulombs, R is the distance in meters, and K is the proportionality constant called as Coulombs constant with an approximate value of 9 times 10 raised to 9 Newton meter squared per Coulomb squared. We need to remember the value for Coulombs constant because this will pop out in several equations as we study electrostatics. Also note in the equation, note that only the absolute value of the product of Q1 and Q2 is determined because what we are trying to solve, or as we solve for the electric force, only the magnitude of the force is to be computed. The force magnitude is always positive. However, the electric force is a vector quantity, which may be positive or negative depending on its direction. Its direction along the line joining Q1 and Q2. The vectors representing the force that Q1 and Q2 and vice versa are pointing towards each other for attraction and away from each other for repulsion. As common knowledge, we know that opposite charges attract each other and same charges repel. So when charges are like signs, such as positive, when the two charges Q1 and Q2 are both positive, then it will have a repulsive force, as well as if they are both negative. And on the other hand, if the charges are unlike signs, either Q1 is positive and Q2 is negative, or the other way around, they will have an attractive force. Now let's look into a sample problem. Two small conducting and identical spheres, A and B, have charges negative 25 nanocoulombs and positive 15 nanocoulombs respectively. They are separated by a distance of 0.02 meters. Question A, what's the magnitude of the electric force between two spheres? And is the force attractive or repulsive? And then for question B, the spheres are then allowed to touch each other and then separated. What's the magnitude of the force between the two spheres? And is the force attractive or repulsive? So for question A, what are our given values? So we have here your charge for A, which is negative 25 nanocoulombs. And then we have charge for B, which is positive 15 nanocoulombs. And then we have R as well at 0.02 meters. So we are asked for the electric force. And to solve for electric force, we can use the Coulombs law, where electric force is equal to the Coulombs constant multiplied by the absolute value of the product of Q1 and Q2 over R squared. Now we can just substitute our values here. But before substituting our values, when you look into the given values, your QA and QB are both expressed in nanocoulombs. And when we work with the Coulombs law, it's important that our charges is expressed in coulombs and our distance is expressed in meters. Therefore, we need to convert our values for charges. So our value for charges here, if QA is negative 25 nanocoulombs, then you can just express it as negative 25 times 10 raised to negative 9 coulombs because nano is 10 raised to negative 9. And QB is positive 15 times 10 raised to negative 9 coulombs. Take note that this is not the proper way in expressing scientific notations, but we can proceed with this one in our calculation so that we do not really, we can easily proceed with our solution. So you have here electric force is equal to the Coulombs constant, which is 9 times 10 raised to positive 9 Newton meter squared per Coulomb squared, multiplied by the product, the absolute value of the product of Q1 and Q2. Then we have negative 25 times 10 raised to negative 9 coulombs times positive 15 times 10 raised to negative 9 coulombs over 0.02 meters squared. So we can cancel out the meters and coulombs. Now you can proceed with inputting or placing the values in your calculators. And what will be the value for electric force? So the electric force should be approximately 8.44 times 10 raised to negative 3 newtons. So your electric force will be about 8.44 times 10 raised to negative 3 newtons. This force will be the force experienced by the two spheres. And there's another question, is the force attractive or repulsive? How would we identify this one? So we look into the values of the charges, or we look into the charges of the spheres. And charge A is negatively charged, sphere B is positively charged. Therefore, they are opposite. And opposite charges will have attractive force. Therefore, electric force, oops. Therefore, electric force is electric force is attractive. Since they are opposite. Question. Now let's have question B. The spheres are then allowed to touch each other and then separated. So our identical spheres A and B with charges negative 25 nanocoulombs and positive 15 nanocoulombs are directly touching each other, which will result to the sharing of charges. And according to conservation of charges, the charges will be distributed among the two spheres. And since they are identical, then the charges will be shared among these two spheres equally. Since again, they are identical spheres, which means they have the same radius. So for B, before interaction, the charges of our spheres is negative 25 nanocoulombs for A, and for sphere B, it's positive 15 nanocoulombs. So we need to solve for the total charge. So the total charge of the isolated system is, you have negative 25 nanocoulombs plus positive 15 nanocoulombs. And we will get negative 10 nanocoulombs. So this negative 10 will be shared into the two spheres, which means both of our spheres, they will have equal charges, which is equal to negative 5 nanocoulombs. Or we can rewrite that as negative 5 times 10 raised to negative 9 coulombs. So if this is the value of our charges now, to solve for the electric force, again using the Coulombs law, so that's the Coulombs constant multiplied by the absolute value of the product of Q1 and Q2 times R squared. So again, Fe is equal to 9 times 10 raised to 9 Newton meter squared per Coulomb squared multiplied by, so we have negative 5 times 10 raised to negative 9 coulombs. We square it because, again, your Q1 and Q2 are the same, over 0.02 meters squared. Your electric force, this will be cancelled, and this one. So we're left with newtons. Our electric force will be 5.625 times 10 raised to negative 4 newtons. So that will be the value of our electric force. And is the force attractive or repulsive? Since both QA and QB have the same charges, which is negative 5 nanocoulombs, they are both negative, and like charges will have repulsive force. So that's for Coulomb's law. Thank you very much for paying attention. See you in our next lesson.